Okay, let's start. I'm going to discuss paper number 4. Paper number 4 first. Applied paper. Okay, take it. ඔයාලට මේකේ ලොකු ප්‍රශ්න නැත්තම් ඔයාලට දීලා තියෙන අනිත් පේපර් එක එමීට කරගෙන යන්න පටන් ගන්න. මම ඩිස්කෂන් එකේ වුණාට කරගෙන යන්න. අපිට මේ අන්තිමටම GIT exam එකකින්ද ඩිස්කස් කරන්න බැරි වුණ හින්දා අද ඒක ඩිස්කෂන් එක කරනවා. Okay, question number 1. Question number 1, part A. A train takes 5 minutes to cover distance 3 kilometers between P and Q. 3 kilometers. 5 minutes. It accelerates and maintains speed 40 kilometers per hour. The acceleration and maintains speed until it's and then retardation F1. Here retardation, the acceleration, then time, velocity given kilometers per hour, and time let's take hours, acceleration alpha, reach velocity 40, maintain his speed until it's brought uniformly to rest at Q. If the train takes 3 times as long as the deceleration it does to accelerate. Here time t, here 3t. Take angle beta. Then total time 5 minutes. Then 5 divided by 60 hours. 5 divided by 60 hours. Therefore, total displacement 3 kilometers. Then full area 3 kilometers. Then 3 equal half into 40 into total time here 5 divided by 60 plus here this 5 divided by 60 minus 40. Area of this trapezium. Full displacement 3 kilometers, half into here 40, total time in hours 5/60. Then here uniform velocity time, then total 5/60 minus 40. Then simplify. 20. 320, 5/60. 1, 12. 1, 12. Then 1/12, 1/12, 2/12, 1/6 minus 40. Then multiply by 6, 18, 20, 20t. Therefore, time equal 2 divided by 24 times 20. Here 2 divided by 24 times 20. 10. 1/240 in hours. 1/240 in hours. Therefore, t equal 1/240 times 60 in minutes. One-fourth minute. Then acceleration time 1/4. Acceleration time 1/4. Find the time taken by the train to accelerate. Here the time 1/4 minutes. Okay. Then question number 2. Here check simplification. Particle of mass 5 kilograms Here 15 newtons pull along rough horizontal surface by string which inclined 60 to the horizontal. Here 60 to the horizontal. Take this force P. And its acceleration of the particle is 9/3. Coefficient of friction 3/2. Here mark reaction R. Here F. F equal mu R. Then mu value 2/3. Here tension T. R mean vertical forces mu R. Okay. Now resolve vertically. R plus T sin 60 equal 50. Then R equal 50 minus T sin 60 root 3/2. Then horizontally F equals MA. T cos 60 minus F equal mass 5, acceleration 9 divided by 3. 9 divided by 3. මෙතන මේ 9 divided by 3 නෙවෙයි වෙන එකක් වෙන්නේ නැති ගමන් අපි 9 divided by 3 ට හදාගෙන යමු. 9 divided by 3. Now T over 2, F mean 2 over 3, R, here 3, 15. Okay, now we have equations here. Here second equation, first equation, third equation. We need to find tension value. Okay, now do simplification. Here R you put here, then T divided by 2, 2 divided by 3 R, here R 50 minus root 3 T divided by 2 equal 15. 15. Okay, then T over 2, 100 over 3, root 3 divided by 3 T. You cancel 2, 15. Then T take outside 1 over 2, then 1 over root 3, 15 plus 100 over 3. Then T root 3 plus 2 divided by 2 root 3. Then T equal 145 times 2 root 3. 3 times root 3 plus root 2. Here tension. Tension. Resolve vertically. Use F equals MA horizontally and mu given, therefore F equals mu R. Then do simplification. That is question number 2. Question number 2. Do with me. Okay, then question number 3, work power energy question. By using physics knowledge you can do that. 3, inclination alpha and mass of the car capital M kilogram, then mg, resistance R, power P kilowatts, then 10 to the power 3 in watts. Then tractive force F, reaction R dash. Its velocity V and acceleration F. Okay, then use H equal PV first. H mean power P times 10 to the power 3, tractive force F, that instant velocity V. Then F equal 1000 P divided by V. Now upward use F equals MA, F minus R, minus mg sin alpha equal m f, acceleration f. Then f equal 1000p divided by v, take r and mg sin alpha the other side, then r plus mg sin alpha plus mf. Now multiply by v. Then 1000p equal r plus mg sin alpha plus mf times v. Here the relation. Now sin alpha given 1/8, p given 20, r given 40. Maximum speed, when v tends to v max, then acceleration gets 0. When velocity becomes maximum velocity, then further we can't increase the velocity. Therefore, acceleration 0. F0. Therefore, take this relation. Then by 1, substitute them. 1000 p mean 20, r mean 40, m not given, g mean 10, sin alpha 1/8, m times acceleration 0, v max. Here v max, when acceleration 0, velocity v max. Now simplify. Here v max equal 2000 divide by 4 plus m over 8. 4 plus m over 8. Here m must be given to find numerical value. That is question number 3. Okay, continue. Okay. Then question number 4, simple harmonic motion question. We haven't done that one yet, therefore I'll skip that. Question number 4. Question number 5, projectile one. Let's do that. Question number 5. A particle is projected from a point O with initial speed 30 meters per second and to the horizontal inclination, let's say theta. A particle pre-projected from a point O with initial speed 30 to pass through a point which is 40 from O horizontal and 10 above O. Here 40 meters and vertically above 10. It passes through like this. Now take AB point. For this projectile, let S equal ut plus half at square. AB motion first horizontally, 40 equal 30 cos theta times t. First relation vertically, then 10 equal 30 sin theta times t, g divided by 2 t square. Now put t value here, 10, cancel 10, 10, 10. Then 1 sin theta. T mean 30, 40 divided by 30 cos theta, 1 over 2, 40 divided by 30 cos theta. Substitute t value here. Now simplify. Then 1 equal 4 tan theta, 16, here 2 times 9 cos square theta. Simplify further. 1, 4 tan theta, 8 over 9 sec square theta. Then multiply by 9, 36 tan theta minus 8 sec square means 1 plus tan square. Now we have quadratic relation. Then further simplify. Then 8 tan square theta minus 36 tan theta. Here minus 8, 9, 17 equals 0. Take this relation. Now it is given that there are two possible angles. So if there are two possible angles, say here we have two solutions, tan alpha and tan beta. Here that is given in terms of tan quadratic. No? Therefore angles given alpha beta, therefore you take roots tan alpha and tan beta. Then root sum tan alpha plus tan beta minus 36 divided by 8, tan alpha tan beta 17 divided by 8. Here it is. Then tan alpha plus beta equal tan alpha plus tan beta 1 minus tan alpha tan beta. Here this is roots relation. Tan alpha plus tan beta minus 36 over 8, 1 minus tan alpha tan beta 17 over 8. Then multiply by 8, minus 36, 8 minus 9, 4. Okay. Simple projectile correction, but need to apply quadratic relations. Question number 3. මෙතන R 400 දීලා තියෙන. 400 then 40 plus m over 8. Okay. Continue. Okay, that is question number 5. Now question number 6. Here a rod here weight W, here rough rod, reaction say R1, there will be friction F. R2, A, B. Rough pegs A and smooth pegs C. Here A and C. Here M mean midpoint. Then MC equals CB. CB equal AC over 2. AC divided by 2. Here AC no, divide by 2 means here same length. You take here L, one length L. Here L, here L, here L. Find coefficient of friction at A and the normal reaction. Here 30. Then first resolve along the rod. Resolve along the rod. Then F equal W sin 30. Then W over 2. Then take moment about A. Then W into here L cos 30 equal R2 into perpendicular distance here L, 2L. Here L, 2L. Simplify. Then R2 root 3 W divided by 4. Coefficient of friction and normal reaction at C. Here normal reaction. Then mu value equal F divided by R. F mean W over 2. R mean root 3 W divided by 4. 2 over root 3. Here coefficient of friction. That is question number 6. Then question number 7. A, B, C, D quadrilateral given. A, B, C, D, AB equal DC given. AB vector equal DC vector. Therefore say AB equal DC and AB parallel to DC. DC. Therefore opposite sides equal and parallel. Therefore, ABCD is a parallelogram. That is question number 7. Then question number 8. A uniform solid is in the form of cylinder of radius 2a and height 2h. Here cylinder here height 2h, radius 2a. Cylindrical hole of radius a and height h is there. Here radius a, height simple h. Then object, mass, center of gravity. Find the center of gravity of the remaining solid part. Then take here x-axis, here y-axis, then here y bar 0, y symmetry y bar 0. Then object full cylinder, then small cylinder, then the remaining part. Then pi 2a square 2h, pi a square h, then remaining part pi 2a square 2h minus pi a square h. Then center of gravity here h, here h by 2, here x bar. Now take moment about x-axis, y-axis. Then pi 2a square into 2h, pi a square h x bar. Here product of these two equal product difference. Pi 2a square 2h h minus pi a square h over 2. Then pi a square h cancel. Then here 4 8 minus 1 x bar. 4 8 h. Here h divided by 2. Now subject x bar. 16 15 h divided by 14. Here the center of gravity. Complete. Question number 9, probability part. Question number 10, statistic part. Then I'll skip that one because we haven't done that yet. එතන මේ root sum එක minus b of a 36 of 8 plus answer minus 4. Okay, do up that. Take time. Okay. Then question number 11, linear motion and relative velocity question. Question number 11, part A. Here A, B, C, H. Here A divided by 3, A divided by 3, A divided by 3. Uniform retardations F, 2F, 3F. At this point, velocity U. Okay. Now let's sketch this. Here time, velocity, initial velocity U, then retardation F. Then next retardation 2F. Next retardation 3F. You sketch this way. These are successive displacements. A by 3, A by 3, A by 3. Then take this angle alpha, take this angle beta, take this angle gamma. Then take velocities v1, v2. Take time t1, t2, t3. Those are times. Now we have successive displacements, then write displacement relations and acceleration relations. Then here this area A divided by 3 half into U plus V2 into T1, here this area. Then A by 3 1 over 2 V1 plus, here V1 plus V2 T2. Here A over 3 1 over 2 V2 into T3, third relation. Here trapezium area, then trapezium area, next triangle area. Then here by the side write down acceleration relations. Tan alpha F, that is retardation, U minus V1 over T1. Then tan beta 2F, V1 minus V2 over T2. Tan gamma V2 over T3, that is 3F. Here 4, 5, 6. Here we have 6 unknowns. Then this simplification little hard, but if you do this way, if you multiply these two, you can cancel time. If you multiply these two, again you can cancel time. Here also same. Then 1 into 4 plus 2 into 5 plus 3 into 6. Do this way. Then A over 3 times F. A over 3 times 2F. A over 3 times 3F. Then left side here half common for each case. Here when you multiply these two, you can cancel T1, then the other part will be difference of 2 squares. Then U square minus V1 square. Then next V1 square minus V2 square. Then next V2 square. Then very easily we can simplify them. Okay, here it is. Then AF divided by 3, 1 plus 2 plus 3 equal U squared over 2. Okay, 2, 5, 6, 5, 6, 3, 2, 2AF, U squared over 2. Now, F value equal U squared over 4A. U squared over 4A. Find the velocity of the bus on reaching the point B and C in terms of U and V. That means V1 and V2 need to find. Here, this is the best simplification technique. Okay. Now, 3 into 6. A over 3, 3F. Here half v2 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 squared. Then v2 equal 2af root. Here the velocity. Then 2 into 5 a over 3 into 2f 1 over 2 v1 square minus v2 square. Simplify 4af over 3 v1 square v2 square 2af. Okay, now simplify. v1 10 af divided by 3. Here 4 2 6 4 10. 10 af over 3. Here are the velocities at B and C. Practice this simplification. Huh? Then the total time, therefore total time T1 plus T2 plus T3. Then here T1 equal u minus C1 over f. Here T2 equal v1 minus v2 over 2f. T3 equal v2 over 3f. Okay. Now get common denominator 6f. 6f. Here 6u, 6v1, 3v1, 3v2, 2v2. Now continue simplification. ඔයාලා මේ papers ගෙදරින් හදාන්න try කරලා තියන්න. හරිද? Okay. 6u minus 3v1 and minus v2 6x f separate denominator. Take u divided by f. Then 6 over u. U divided by f, 6 over 6. 1 v1 10 af over 3 v2 2 af root divided by u. U over f 1 here 30 plus root 2 af root divided by u. Here u equal 2 af root 2 root af. Then put it here. Then u of f here divide by 6 6u 12. Then u equal 2a fruit. F equal u squared of 4a. Root 30 plus root 2 divided by 12. Then 4a divided by u 1 minus root 30 plus root 2 divided by 12. That is the total time. Okay, complete. එතන linear motion question එක simple. හැබැයි මෙතන මේ simplification එක තමයි hard වෙලා තියෙන්නේ. ඒතර ඔයාලා ස්පෙෂල් ඒ පොයින්ට් එක සිම්ප්ලිෆයි කරන ටෙක්නික් එක ප්‍රැක්ටිස් කරන්න සක්සෙසිව් ඩිස්ප්ලේස්මන්ට් එක. මේ මල්ටිප්ලිකේෂන් එකේ ඩිෆරන්ස් ඔෆ් two squares අපිට සෙට් වෙනවා. complete Then 11 part B, relative velocity question. 11 part B, a ship A observe another ship B 20 kilometers due east of A. Here 20 kilometers. B is steaming north at speed 24 kilometers per hour. After 24 minutes, if the ships are found to be nearest to each other at distance 12 kilometers, find the velocity of A. Okay. Now relative motion. Let's take relative motion something like this. Here relative path. Locus of B with respect to A. Then here shortest distance 12 kilometers. Take this angle alpha, then sine alpha 12 over 20. 12 over 20 divisible by 4, 3, 5, 3, 4, 3, 5. Here sine alpha. Here t equals 0, here t equals 24 minutes. 24 minutes. Then here take this displacement, let's say A equal 20 square minus 12 square root. Here 4 common, take outside. 5 square minus 3 square root. Here 4, 16 kilometers. Then here the velocity of B with respect to A, relative velocity 16, displacement 16 divided by time 24. 24 divided by 60, here kilometers per hour. Here take this displacement and corresponding time given 24 minutes. Then displacement divided by time, relative velocity. Now simplify. 12 divisible here 2, 5, 8, 2, 40. Here relative velocity 40 kilometers per hour and its direction at an angle alpha. Then velocity of B with respect to A at an angle alpha, alpha mean 5 over 3, 3 over 5, 40 kilometers per hour. Then velocity of A with respect to Earth, VAB, VBE. Here AB opposite direction, alpha 40, BE upward 24. Then here 40 cos alpha, here 40 sin alpha minus 24. Then here 40 sin alpha, 3 over 5, 24, 0. Then no horizontal velocity. Therefore, velocity of A with respect to Earth, here 40 cos alpha, 40 cos alpha, cos alpha 4 over 5. Here sin alpha 3, 5, then here 4. 4 over 5. (32). Then 32 kilometers per hour. Here the velocity of A. Velocity of A. Then by using general definitions, you can find relative velocities. Okay, complete. Here shortest distance given, one object velocity given, then you guess relative path. First guess relative path, then here 20 kilometers, shortest distance 12. Therefore, you can find resultant velocity direction. That means velocity of B with respect to A. Then from here to here, time given 24, then by take displacement and divide by time, then you can find relative velocity. Likewise, you can complete it. That is question number 11 part B. Complete. Then question number 12, part A. 12 part A. A golf ball initially at rest is dropped from horizontal surface. Again with velocity v given. Here velocity v, it moves like this. Then let's put upward s equal ut plus half a t square this motion. Then displacement 0, initial velocity v, t minus g over 2 t square. Then cancel t. 2v divided by g. Here general time. Then if particle is projected with velocity v vertically upward, then the time of flight 2v divided by g. Then thereafter the motion, you remember here collision part, here the velocity v, then rebounds in velocity ev, rebounds in velocity ev. Just remember that one. Huh? When it hit with the floor or when it hit with a wall, here velocity u, then rebounds in velocity eu. Here it is. Therefore, next case, with velocity ev, it moves like this. E mean coefficient of restitution. Collisions කරලා නෑ මම. ඒ වුණාට මේ point එක වල ස්පෙෂල් දැන් මතක තියාගන්න. ඒක මම කියලා තියෙනවා වගේ මතකයක් තියෙනවා collisions කරලා නැති වුණාට. Coefficient of restitution E. පොළවේ වදිනකොට rebounds වෙන්නේ EV ගෙන්. EV. Then equal coefficient of restitution. Then again rebounds in velocity E. Again multiply by E. E square V. Then again multiply by E. E cube V. Again multiply by E. E to the power 4 V. Likewise it goes like this. It bounces. Okay. Then total time. Here first time 2v divided by g. Next time replace velocity by ev. 2ev divided by g. Next 2, now velocity is square v divided by g. Replace this v by ev, e square v. Likewise it goes so on. Infinite series rebounds in. Therefore take 2v over g outside, 1 plus e square plus, it goes like that. Take this series 2v over g. Here velocity series sum given 1 plus e square, sum given 1 minus e to the power minus 1. Therefore 2v divided by g, 1 minus e. Here by geometric series sum you can get this one directly, and here especially it is given 1 plus e square plus up to infinite series sum 1 minus e to the power minus 1. That is given. That is question number 12 part B. 12 part A. Then 12 part B. Here take this system. Here mg. Here kmg. T R1, R2. Here 60, here 30. Then take acceleration F. Then use F equal ma, system of Paulic action, simple m along the surface upward, then T minus mg sin 60 equal m F. Say 1. Then kmg downward, kmg sin 30 minus t equal km f second. Then 1 plus 2 kmg over 2 sin 30 mg sin 60 root 3 over 2 mf plus kmf. Now subject f. Then f equal, take g over 2 outside, k minus root 3 divide by 1 plus k. For k greater than root 3, for k greater than root 3, f greater than 0. Here this part positive, f greater than 0. Therefore, m moves towards P. Here this is P. In that case, when k greater than root 3, then acceleration positive. Acceleration positive means it moves towards P. Because initially start with 0 velocity. 0 velocity, positive acceleration, then definitely move in that direction. Okay, complete that. That is question number 12. Okay. Now question number 13, circular motion question. Question number 13, circular motion question. A particle A of mass m hangs by an extensible string of length simply from a fixed point O. In string is initial vertical and the particle is given the horizontal velocity nag root. Okay. Here it is now. Here initial velocity take u nag root. So to complete a full circle, so at this position, let's take general position. Here mg, tension T, let this angle theta, let this velocity v, here E0 level. Then we know for vertical circular motion, need to use conservation of energy and towards center F equals ma. Then conservation of energy, half mu square equal half, here no potential energy, here potential energy and kinetic energy both there, half mv square plus mgh. Here radius simple, let's take a. And here a minus a cos theta. A minus a cos theta. Then cancel m. U square in NHE. V square minus plus 2HE 1 minus cos theta. Then corresponding velocity V square equal HE n minus 2 plus cos theta plus 2 cos theta. Here say 1. Then towards center F equals ma, T minus mg cos theta equal mv square divided by radius. Then T equal mg cos theta plus m over a v square. Then put this one, ag n minus 2 plus 2 cos theta. Then simplify a little. Then mg n minus 2 plus 3 cos theta. Here it is now. Here second relation. Tension variation with theta, here velocity variation with theta. Then to complete a full circle, then when theta equal pi, t value must be greater than or equal 0. That must happen. Then mg n minus 2 3 cos pi must be greater than or equal 0. Here the condition. Then if we complete full circle, then here highest position tension must be positive or 0. If tension negative, then definitely that leaves the circle. Then cos pi mean minus 1, then n minus 5 greater than 0, n greater than 5, greater than or equal 5. Here the condition to complete a circle. Same thing we have done, same relations we have done when we are doing theory part. Okay, now further question. Further, when the string OA reach horizontal, when it comes to horizontal position, so now this position, initial velocity u, nag root, then take here v1, then v1 equal, substitute pi over 2 here, v1 square ag n minus 2 cos pi over 2. Then cos 90 0, n minus 2 ag v1, whole thing root. Here velocity. Then it collides with another particle. Second particle same mass. Therefore here mass simple m. There's another particle m. M and m. Then they move towards together. Then take velocity v2. Then for this collision, use conservation of momentum upward. Then mv1 equal here 2m v2. Then v2 equal v1 over 2. v1 mean n minus 2 ag root divide by 2. Here v2. Okay. Find the least values of value of n for the vertical circle can be completed. Then thereafter it moves circular path. Now you take here velocity v2, mass 2m, then get highest position again. Take this velocity v3, then mark forces here 2mg, say tension T1. Then take again E0 level here. Then conservation of energy, half 2m here, full mass 2m, v2 square, half 2m here v3 square plus 2m gh mean a. Here height simple a. And cancel 2m, then v3 square equal v2 square minus 2ag. Okay. Then v2 square known, n minus 2 ag divided by 4 minus 2ag. Then simplify, v3 square equal 8, 10, n minus 10 ag divided by 4. Here take this relation, that is v3. Then at the highest position, tension must be positive to complete the circle. Therefore, put downward F equals ma, T1 plus 2mg equal 2m, acceleration v3 square divided by 2. Ne? Then radial acceleration v square divided by a, v3 square divided by a. Here velocity v3, then radial acceleration v square divided by r, v3 square divided by a. Okay. Now you can take that. Now to complete circular motion, for full circular motion, vertical circular motion, then T1 must be greater than or equal 0. Therefore 2m over a, v3 square minus 2m g greater than or equal 0. Simplify. Then v3 square greater than or equal ag, v3 square, we know that, n minus 10 ag divided by 4 ag. Then n greater than 14. N greater than or equal 14. When n greater than or equal 14, that can complete a full rotation. Okay, complete it. 14 simple harmonic motion question, then I'll skip that one for now. And let's move to question number 15. Question number 15 එක part A B අපි ළඟදී කරාද? paper එක discuss කරා වගේ මතකයි. mock exam එක discuss කරා වගේ මතකයක් තියෙනවා. කරා? full එක කරානේ? කරානේ? හරි. Okay, then question number 16. Question number 16. Let's do that. Okay. Now question number 16, center of gravity question. So initial part proof I'm not doing for now. Then next part, solid body. Here hemispherical part. Here radius A. Or here midpoint A. Its radius A divided by 2. Then let's get better sketch. Okay, anyway. Put x-axis, y-axis like this. Then mass per unit volume rho. Then object, mass, center of gravity. Then one object hemisphere, the other object hemisphere, then the remaining body. Then mass 2/3 pi, here radius A cube rho. Here 2/3 pi, radius A divided by 2 cube rho, then 2/3 pi A cube rho minus 2/3 pi A over 2 cube rho. Then here center of gravity, we have two coordinates now, not symmetrical, therefore take x, y. Take x bar and y bar. Then here x coordinate 0, y coordinate 3a over 8 minus, according to my diagram it is minus somewhere here. Then here center of gravity, x coordinate minus a over 2 and y coordinate 3a divided by 8. 3 radius mean now a divided by 2. Okay. Need to get this point. Then radius a over 2, then 3 over 8 times of a divided by 2. Negative, negative. Now, by these two columns, you find x bar. By these two columns, you find y bar. Y bar. So here we need finally, before that we need to find center of gravity. No? Find center of gravity. Therefore, 3 pi 2/3 pi a cube rho minus 2/3 pi a divided by 2 cube rho x bar. Take these two columns. 2/3 pi a cube rho times 0 minus 2/3 pi a over 2 cube rho minus a divided by 2. Okay. Product of these two subtract with product of these two equal with product of these two. And definitely center of gravity must in positive x value. Okay, then 2/3 pi a cube rho cancel, 2/3 pi a cube rho cancel, 2/3 pi a cube rho cancel, 2/3 pi a cube rho cancel. Then here 1 minus 1 over 8 x bar, there minus minus plus, here 1 over 8, 1 over 16. A. Here 8, 16, minus minus plus. Then x bar 7, 14. Here 8 cancel, 2, 7, 14. Then here moment about y axis. Then moment about x axis, take these two columns. 2/3 pi a cube rho, 2/3 pi a divided by 2 cube rho y bar, 2/3 pi a cube rho, here minus 3a over 8 minus 2/3 pi a over 2 cube rho minus 3 over 8 a divided by 2. Okay, now simplify this. Simplify. Carefully simplify. Yeah? Then 2/3 pi a cube rho, 2/3 pi a cube rho, 2/3 pi a cube rho cancel, pi a cube rho cancel. Then here 1 minus 1 over 2 cube 8 y bar. Then here minus 3 over 8. Here minus minus plus. Here 1 over 8. Here 3 over 8. A over 2. Okay. 1 over 8, 3 over 8, a over 2, minus minus plus. Now get common denominator, 7 over 8 y bar minus 3a over 8, 3a over 8, 1 over 8, 16. No? Then cancel 8. Then y bar, get common denominator 16, 48, 45, a divided by 16 times 7 minus. 16 times 3, 48 minus 3, 45 minus 16 times 7. Here it is. Then 45a, 16 into 7. 112. Here center of gravity, x coordinate and y coordinate. Okay, do up to that. Okay. Then thereafter it says that in contact with a curved surface, then definitely that must incline somewhat like this. Now center of gravity, x coordinate, here x bar, then corresponding y coordinate parallel to this line symmetrical axis, that is y bar. Then center of gravity somewhere here. Somewhere here. Then weight vertically downwards. Therefore, reaction must be passing through vertically upward. Through the center, passing through the center, then center of gravity y coordinate, here y bar, here chi. It must stay like this. Then only that can be in equilibrium. No? Then forces must be reaction vertically upward, then weight vertically downward. Therefore, definitely this reaction passing through center of gravity as well as center of the sphere. Center of the sphere, it passes through center of the sphere, center of the hemisphere, because that according to the definition of reaction, because reaction perpendicular to the common surface, therefore definitely that passes through center. And to be in equilibrium, then weight and reaction must be equal and opposite. That's why reaction passing through again center of gravity, then only that can be in equilibrium. Okay, then now we need to find angle inclination OA to the vertical. Here OA, here AO to the vertical angle. Here theta, need to find this angle theta. Then tan theta value according to geometry, y bar divided by x bar. Y bar divided by x bar. Then y bar we know 45 divided by 112. 45a divided by 112. Then x bar equal a or 14. 14. Now you can simplify this. Then tan theta 45, 14, 112. Then by this find theta, that is tan inverse value. No? In 112 we know 16 times 7. Here 16 times 7. Then 2, 1, 8, 8. 45 divided by 8. Here the inclination, check simplification. First find center of gravity, then according to geometry find equilibrium condition. Complete. Okay. Question number 17, probability statistic question, I'll skip for now. That is paper number 4. That is paper number 4. Okay, complete the question.